Hey guys, welcome back everybody. Hope you all are doing great. Guys, today in this video we are going to discuss some common concepts of BGP. As you know, BGP or Border Gateway Routing Protocol is a very important routing protocol. And many times interviewer is also asking question from these kinds of scenario. So today in this video, we are going to discuss some common rules of IBGP. IBGP means internal BGP. When we have BGP neighborship within the ES, within the autonomous system number. And guys, this is my scenario. As you can see in my scenario, there are three routers, router 1, router 2 and router 3. And on all the router, I am running BGP number 100 on router 1, router 2, router 3. So that's why between router 1 and router 2, I have IBGP neighborship, as well as between router 2 and router 3, I have IBGP neighborship. Apart from this, here one LAN is connected on router number 1, where I am running subnet 10.1.1.0/24, and one another LAN is connected to router number 3, where I am running subnet 30.1.1.0/24. And between the router, you can see the subnet, like between router 1 and router 2, my subnet is 12.1.1.0/24. Let me write here. Here subnet is 12.1.1.0/24. Here subnet is 23.1.1.0/24. And IP on router 1 is 12.1 here. IP on router 2 is 12.2. IP over here is 23.2. IP over here is 23.3. And on the LAN interface of router 1, my IP is 10.1. And on the LAN interface of router 3, my IP is 13.1. After that, you can see the BGP configuration on all the routers. Like on router number 1, I ran 3 commands under the BGP. Router BGP 100, this command is going to enable BGP on router number 1. After that, I have defined the neighbor. Who is your neighbor? 12.1.1.2, which is the IP address of router 2, and remote AS is 100, right? So it is going to form IBGP neighborship. Their on AS is also 100 and remote AS is also 100. After that, I have advertised LAN subnet in BGP 10.1.1.0 mask 255.255.255.0. So here on router number 1, if you will check BGP table, you will have this subnet 10.1.1.0/24. Then on router number 2, again you can see the BGP configuration, router BGP 100 and neighbor 12.1.1.1 R1 and neighbor 23.1.1.3 R3. So on router number 2, I have defined two neighbor command because there are two neighbors in the BGP. Router 1 is also neighbor, router 3 is also neighbor. But here on router number 2, I am not advertising any subnet in the BGP. And on R3, again router BGP 100, it will enable the BGP as number 100 over here, and the neighbor 23.2 R2 remote AS 100, again it will form IBGP neighborship here, and then I am advertising LAN subnet in BGP. So R3 is also going to install 30.1.1.0/24 in their BGP table. Now I have one question for you. Question is, can 10.1.1.1 this IP address ping to this IP address 30.1.1.1? And please share your answer in the comment section, guys. Just pause the video. You can think. These are the commands. These are the configuration, right? I have not run any other command on these routers. After that, we have verified the BGP neighborship. Let's say, and there is neighborship between router 1 and router 2. I have IBGP neighbor. Between router 2 and router 3 also I have IBGP neighbor. And question is very simple. Can these two LAN communicate with each other? Right? Pause the video and share your answer in the comment section. If you are thinking yes, ping will work, then type yes in the comment section. If you are thinking no, ping will not work, then type no in the comment section. Otherwise, at the end of this video, I am going to show you practically also, right? I have already same lab in the EVNG where I am going to show you the issue, because my answer is going to be, guys, no, ping will not work. Now, if you are thinking, yes, ping will work, if your answer is yes, that means you don't know some basic concepts of IBGP. Let me tell you about this concept. First rule of IBGP is what, guys? Loop avoidance rule. Do not advertise prefixes to your IBGP neighbor which you have received from other IBGP neighbor. For an example, R1 is going to advertise this 10 subnet through update message. It will generate one update message. For R2, update, and in this update message there will be NLRI information, means network information 10.1.1.0 0/24 network layer reachability information. R2. R2 will receive this update message over here. It is going to install it in their BGP table. Next hop IP address will be 12.1. So next hop is also reachable. This prefix will be valid as well as best on router number 2. So router 2 is going to install it in their routing table also. But router 2 will not advertise this prefix to router number 3. Not advertise. Why? Because it is receiving this prefix 10 subnet from their IBGP neighbor. So it will not advertise to their other IBGP neighbor. If R3 is their eBGP neighbor, then definitely it will advertise. But if it is IBGP neighbor, then it will not advertise. This is loop avoidance mechanism, or you can say rule for IBGP neighborship. Right? For IBGP neighborship, this is rule. First rule. That means R3 will not have this subnet 10.1.1.0/24 in their BGP table. In the same way, R3 is going to advertise this 30 subnet to router number 2, but router 2 will not advertise it to R1. Again, same rule, it is receiving prefixes from their IBGP neighbor, so it will not advertise to other IBGP neighbor. That means R1 will not have 30 subnet in the BGP table, correct? If you will check the BGP table of R1, so here you will have one subnet, valid as well as best 10.1.1.0/24, and next hop is going to be 0.0.0.0 self-advertised prefix. If you will check BGP table of R3, then you will have 30 subnet only here, valid as well as best 30.1.1.0/24, and next hop is again 0.0.0 self-advertised. If you are going to check the BGP table of R2, guys, so here we will have both the subnet, valid as well as best 10.1.1.0/24. Next hop IP address is 12.1.1.2, correct? One more subnet will be there, that is again valid as well as best 30.1.1.0/24, and next hop IP address is 23.1.1.3, which is reachable. That means this prefix is also valid as well as best. So router 2 is going to install both the prefixes in their routing table. But issue over here is between R1 and R2, you can see on router number 1 I don't have 30 subnet, on router number 3 I don't have 10 subnet, right? So definitely ping will not work. To break this rule, because here we know that loop cannot form because my physical topology is not in loop, there is no any redundant path, there is no any redundancy, there is only one link between source and destination. So in this case loop cannot form. So here I have to break the rule of IBGP. What we can do, we can configure route reflector RR. I can make this router as RR, router route reflector. I can say your neighbor router 3 is route reflector client, or router 1 means 12.1 is your route reflector client. Here on router number 2 I can add one command here, neighbor, and let's say 12.1.1.1 and route reflector client. So what will happen now? Now router 2 is receiving prefixes from their client neighbor, so definitely it will advertise to non-client neighbor. Second scenario, if it is receiving prefixes from non-client neighbor, then definitely it will advertise to client neighbor. So now router 1 will have 30 subnet and router 3 will have 10 subnet, right? This is concept of route reflector, guys. If you don't know the route reflector, you can watch a detailed video is there on the channel for route reflector. You can watch that video, right? You can check the BGP ccie playlist on my YouTube channel. There you can learn route reflector in detail. In route reflector there are three types of routers: server, client and non-client, right? So rule said what? Rule is whenever you are receiving prefixes to your non-client neighbor, then you will not advertise it to other non-client neighbor. If you are receiving prefixes to client neighbor, then definitely you will advertise to other non-client neighbor. Or if you are receiving prefixes to non-client neighbor, you will advertise that to client neighbor, right? So in one case only, server router will not advertise the prefixes when both the neighbor are non-client. So here I have said client, and again this router 2 is server and this neighbor is non-client. So in this case prefixes will be advertised. After configuring route reflector, can these two subnet communicate? Now if you are thinking yes, these two subnet can communicate, then you can type yes, after route reflector, LAN can communicate. If you are saying no, after configuring even route reflector, communication will not possible. Communication is not possible. Communication will not happen. Then tell me the reason. Right? Pause the video and share your answer in the comment section. Yes or no. After configuring route reflector. Before configuring route reflector, definitely answer is no. If your answer is yes, then you can revise your answer now again. But after configuring route reflector, why I am saying no? Praful, after configuring route reflector, ping should work. There should be reachability. No, guys. Now, the second rule of IBGP. First rule of IBGP is loop avoidance. Second rule is next hop rule. Whenever a BGP router advertise prefixes to their IBGP neighbor, it not modify the next hop. It does not modify the next hop address. So when R1 is going to advertise this submit 10.1.1.0/24 to R2 through update message, next hop IP address is going to be what, guys? 12.1.1.1. When router 2 will advertise it to R3 after configuring route reflector, it will advertise. But R2 will not modify the next hop, right? So R3 will receive 10 subnet 10.1.1.0/24 with next hop what? 12.1.1.1. Now tell me, is 12.1 reachable from R1, R3? Answer is again no. R3 cannot ping this IP address, right? So as next hop is not reachable, this prefix is only valid, not best, not best. So router will not install it in routing table, right? You will only find this prefix in BGP table. In the same way, R3 will advertise 30 submit to R2 and next hop IP address is going to be 23.3. R2 will advertise it to R1 after configuring route reflector, but it will not modify the next hop address. So R1 is going to receive 30.1.1.0/24 with next hop 23.1.1.3, which is again not reachable. Because of that, this prefix is only valid, not best. So router 1 is not going to install it in routing table. That's why communication will not happen. Still we have issue, right? So what we have to do now? Now we have to tell to router 2 to update the next hop IP address. Here we have multiple options, right? I can configure one static route on router number 3 for 12.1 and one static route for 23.3 on router number 1. So once next hop IP address will become reachable, prefix will become best and valid in the BGP table and router will install it in routing table. This is first option. Second option, here between router 1 and router 3, I can run any IGP protocol to make reachability between 12.1 and 23.1. Second option, right? Any IGP protocol, you can run OSPF, you can run EAGRP, REAP, or you can configure the static route. But default route will not work. If you are thinking, Praful, what if I will configure one default route on router number 1 towards router 2 and one default route on router number 3 towards router number 2? That will not work, guys. Even 12.1 can ping to 23.3, but that will not work for BGP, right? So second case can be enabling IGP protocol over here. And third case is, which is the practical case, which is the actual method of real time. Same method we are using in the production network, that is updating next hop IP address on router number 2 with the help of route map. With the help of route map. Okay. So you can use any method to update the next hop IP address, and after that these two LAN can communicate. Okay. So hope it is clear. Now I am going to show you practically. So to show you practically, let me so this is lab here. Hope it is visible. Wait, hope it is visible. You can see here I have access of router 1, router 2 and router 3, and here is my configuration in the notepad, right? You can see we have similar configuration on router number 1, config t, then interface f0/0 no cert IP address 12.1, then interface f1/0, which is my LAN interface where I am running IP 10.1.1.1, and then router BGP 100, router ID 1.1.1, neighbor 12.2, remote ES 100, and after that I am advertising LAN subnet in BGP. This is configuration of router 1. In the same way, here I have configuration of router 2. Again on interface f0/0 IP address is 12.2, on f1/0 23.2, and then router BGP 100, router ID 2.2.2, and there are two neighbor command. Right, this is 12.1 is the IP address of router 1, and 23.3 is the IP address of router 3. In the same way, here I have configuration of R3 router 3, interface f0/0 23.3, f1/0 20.1, router BGP 100, router ID 3.3.3, neighbor router 2, and after that I am advertising the LAN subnet. Let me run these all commands on router one by one. Let me copy R1 configuration first. Here is my R1 configuration. Copy and let me paste it on R1. Paste. So you can see all the commands are accepted over here. If you will check the BGP table, so IP BGP, you can see 10.1.1.0/24 is there. Next hop IP address is 0.0.0 because it is self-advertised prefix. For self-advertised prefix, you can check wait value 32768. But this prefix is only valid. Why not best? Soon this prefix will become best also. It will take some time. Till then, I am going to paste R2 configuration. Let me copy R2 configuration over here. One minute. There is R2 configuration. Let me copy it and let me paste it on R2. All good. Then finally R3 configuration. Copy and let me paste it on R3. Done. Now we can verify the BGP neighborship. We can verify the BGP table. So let's verify the BGP neighborship and BGP table from R1. Now so IP BGP. Now you can see still this prefix is only valid, not best. So IP interface brief. Okay. So IP BGP summary. Here we have BGP neighborship between router 1 and router 2, and on router number 2, so IP BGP summary. Here you can see I have two neighbor 12.1 and 23.3, means router 1 and router 3, and so IP BGP. There is no any prefix in the BGP table. BGP is guys slow protocol. It will take some time. Wait. So IP BGP summary. Here also you can see we have BGP neighborship, and so IP BGP. Let me check BGP table. This prefix is still only valid, not best till now. It will take some time updating their database. Now on R1, so IP BGP. Now you can see on R1 BGP, in the BGP table 10.1.1.0/24 prefix is there, and this prefix is valid as well as best. Next hop is 0.0.0. Now R1 is going to advertise it to R2. So let me take you to R2 and let me show you the BGP table. So IP BGP. Here also you can see now in the BGP table I have 10 subnet as well as 20 subnet, right? So router 3 is advertising 20 subnet, router 2 is router 1 is advertising 10 subnet. Next hop for 10.1.1.0/24 is 12.1, and next hop for 20 subnet is 23.3, means router 3 IP address. Correct? Okay. So on router number 2 we have both the subnet and both the prefixes are valid as well as best, because both the next hop IP address are reachable. So IP route BGP. It will install it in BGP routing table also. Here you can see both the subnets are there. But on R3 guys, I will only have 20 subnet in the BGP table. Here you can see, and on R1 I will have only 10 subnet in BGP table. Done. So let's break the loop avoidance rule for the iBGP. Let me configure route reflector here to R2. Go to config T and here say neighbor or router BGP 100 first, and neighbor, either I can say 12.1 is your route reflector client, or I can say router 3 is your route reflector client. Both will work. So I'm saying neighbor, let's say 12.1.1.1 and route reflector client. After configuring route reflector over here on R2, I am expecting prefixes in the BGP table of all router. Let me show you the R1 BGP table. So IP BGP. Now you can see 20 subnet is there in the BGP table, right? On R1, 20 subnet is now there. But guys, this prefix is only valid here. You can see note best greater than sign is not there. Why? Because of next hop IP address. Next hop IP address is what? 23.1.1.3 on router number 1, which is not reachable, right? Here if you will check route, so IP route 23.1.1.3, you can see there is no any route available on router number 1. So that's why ping is like it will not install in the routing table. So IP route BGP. In BGP routing table, I don't have any prefix. In the same way, on router number 3 also you can verify the BGP table now. So IP BGP, you can see 10 subnet is there, but this prefix is only valid, not best. Reason? Next hop. Next hop is not reachable. So how to fix it? What we can do? First option, I can configure the route. Here I can say IP route and 12.1.1.1 255.255.255.255 and exit interface F0/0. Now route is there for next hop IP address, so IP BGP. Now you can see soon this prefix will become best clear IP BGP star soft in, and so IP BGP. Now you can see right here 10 prefix become now best because route is available for next hop IP address. So IP route 12.1.1.1. Now you can see this next hop is reachable, right? So that's why it have installed prefix in BGP routing table. On router number 1 also we can configure the static route, but guys we will not use this method. Let me remove the static route from router number 3 also. I am saying no to this command. Another option, you can configure any IGP protocol on the all WAN link, right? And the third option is route map. Now I am going to tell to router number 2 to always update the next hop IP address, right? So on R2, let me create a route map. 2 route map is required here. Route map name is, let's say, next hop for R1. Next hop for R1, and here I am saying set IP next hop. What should be the next hop for router number 1, guys? Whenever router 3 is advertising this 20 subnet to router number 2, next hop 23.2. What we want when router 2 is advertising? What we want here? What we want when router 2 is advertising the prefixes to R1, next hop should be their exit interface IP address 12.1.1.2. So let me configure this. Very simple. Here I can say set next hop 12.1.1.2. That's it. Then I will create one more route map here. Route map for R3. And here I am saying set IP next hop. When R1 will advertise prefixes to R2, next hop 12.1. When R2 will advertise prefixes to R3, next hop should be 23.2. So let me say 23.1.1.2. Exit. And now I will call these route map with neighbor command, router BGPS number 100, and say neighbor 12.1.1.1 and call route map. Which route map I will call here? I will call this route map over here. For 12.1 I am applying, right? So it should set this next hop IP address 12.2. So let me call this route map next hop for R1. And in which direction again, guys? In odd direction, whenever you will advertise the prefixes. And I can call one more route map here with another neighbor 23.1.1.3 and route map. And this time route map name is going to be this one. Next hop for R3. And again direction is out. And clear IP BGP star stopped out, right? Now let me take you to R1 and let me show you the BGP table. So IP BGP. Now you can see next hop is now 12.1.1.2 for 20 subnet. That's why this subnet is valid as well as best. So now router is going to install it in routing table. So IP route BGP, you can see 20 subnet is there in the routing table. And on R3, so IP BGP. Again here you can see next hop for 10 subnet is 23.2. That's why this prefix is now valid as well as best. So it will install it in routing table. You can see in the routing table. And now these two LAN can communicate. You can verify the connectivity. Ping 20.1.1.1, source 10.1.1.1. Ping is now working. So these are common basic. These are some common basic concepts of IBGP, and hope now it is clear to you. So that's all for today, guys. If you have learned something from this video, please hit on like button. And if you have any question, query, concern, please let me know in the comment section. And if this video is helpful for you, if you want more videos like this, and first you need to share answer of some previous questions, right? Between the video I had asked you 2 questions, right? So share the answer of those questions. And apart from this, if everything is clear and you want more videos like this, you can say yes. You can say yes in the comment section, right? Yes means everything is clear to you and this video was helpful for you. It will motivate me to make more videos like this, right? So if you have not typed anything in the comment section, then please type yes. Okay, so that's all, guys. I will meet you soon in the next video. Till then, stay safe. Bye bye. That's all for today. Thank you so much for watching.